All right, we got a few people online. First thing you guys want to do is do this little warm up. We'll go through them together in a few minutes. It is important to know, I know this is new for you guys. When we're doing these vectors, when you see a basic vector, we could say it's pointing to points all along the way. And so doing that, I just showed a curve that goes like this. So that's how we're going to be doing it. We're showing vectors from the origin. We can do lines parallel to it, have the same vector notation. So the vector notation is used in two ways, but the default thing is from the origin. It's a pointer, which is a little to wrap your head around because they use it two ways. I agree. So this pic has no relation to that problem. That was just to explain. I better get rid of it before someone goes, what does that have to do with the picture?
Professor Jones, were you going to watch the launch of the Artemis 1 rocket?
I forgot it was today, to be honest.
Yeah, it actually got postponed.
Yeah, next attempted launch is on Friday.
Okay.
Yeah, there was a leak in one of the engines, so they had to postpone it.
Okay.
Sounds like you do.
Well, hopefully for the first part of part A, hopefully you got x equals 2 minus t, y equals 3 plus 4t, and z equals -1 plus 2t. Those are the parametric equations. Hopefully you got that. And what will we do to find the line segment?
I'm hearing make bounds on T.
Make what?
Bounds on T.
Well, t's already bounded. I bounded it from -1 to 3.
Try again.
How could I find the point at t equals -1?
Plug in -1 for T. I'm hearing.
Yeah, it's that simple. So
Yeah.
if we plug in -1 for t, we've got x equals 2 minus -1, which is 3. Y is going to be 3 minus 4 is -1. 3 minus 4. So 3, -1. And we plug in -1 here. We got -1 plus, or -1 minus 2. So -3. So that would be the first endpoint. Second one, I'll just go a little bit faster. We're plugging in 3. So 2 minus 3, x is -1. We plug in 3 for t there is 12. 12 plus 3 is 15. And we plug in t equals 3 here. 3 times 2 is 6. Minus 1 is 5. So -1, 15, and 5. If it helps, if it's while you're getting quicker at it, you can always distribute this t inside and rewrite this as 2, 3, -1 plus -t, 4t, 2t. And that's then do the vector addition. 2 minus t, 3 plus 4t, -1 plus 2t. And that's how we end up with those. How could I find what time restrictions are for the line segment with these same equations?
Do you have a question?
I can't make sense of anything that you've written down.
Here, he has a question about how you got the those boundary points for part A.
Is that equal 3? What does that mean?
These points?
Which point are you talking about, P1 or P2?
I think some of P1, right? So what's that equal 3? P1, what's that? 1.
Did I do something wrong on it?
I think, so he put in t equals -1 for one point and t equals 3 for the other point.
Yeah, it's two different points. That'll be 0.1 and that'll be 0.2. Well, something that might help, picture this is like a straight train, an infinite train, and these are stops. At what time does the train stop? So at t equals -1, where is this train station stopping? At t equals 3, where is the train station stopping? And so that's kind of like what we're doing in part A. And we had to find the position here. So we found this was 3, -1, and 3. This was -1, 15, and 5, unless I screwed up some basic problem there.
I'm pretty sure. But there's also the probability that I could be wrong too. Yeah, I've been known to make algebra mistakes too.
And the question is,
Oh,
where
yeah.
is,
Shocking.
what time stops are these at? So I see -1 is here for X, 3 is here for X here. I've got 4.5, it's got to be somewhere back here. I've got the 4.5, -7, -6. And I see a 0. 0 is between 3 and -1. Somewhere in here is that stop, 0, 11, and 3. So how could I find what times are associated with those stops?
Do you think it's possible to turn on the cameras to the guys?
Not
Probably be a
very
better-
easily.
Probably better perspective.
Let's see.
Glass with the question, I mean.
It's not very easy. Let's see. All right. Can you see your adoring audience, Mr. Jones?
I can see my, there's a good group of people there. I like it. Hey, everybody.
Can they not see? Let's see. See them. Yeah, and this doc cam is kind of in the way.
No, I can see a good portion of them.
But what about my beautiful face?
Yeah, I would get tired of looking at that thing anyways.
Yeah, filter our questions through you. We ask questions, you ask her again.
Well, that's just so that just in case he doesn't hear you.
Right. It's a matter of where the speaker is. You guys are or microphone is. You guys are a lot farther from the microphone than he is.
Yeah, it's just a matter of you guys just kind of speak it up.
So in part A, we plugged in time to find our position. In part B, what should we plug in to find our time?
Probably the X, Y, Z and finding time. Backward.
Solve B.
I heard plug in X, Y, and Z. Is that what someone said?
Yeah.
Yeah.
That's what we need to do. And to be honest, you should really only need to do one, but you might check two just in case. So for A, I'm going to use the X and maybe Z because they're smaller. So X, I've got 2 minus T. I'm going to plug in the 4.5. And I subtract 2. I got 2.5 equals negative. And so T equals negative 2.5. Does that generate, is that going to work on Z? If I plug in negative 2.5 for T here, negative 2.5 times 2 is negative 5, minus 1 is negative 6. That matches up. If I plug in negative 2.5 and Y, will it work for negative 7? Negative 2.5 times 4 is 10, negative 10. Negative 10 plus 3 is negative 7. So it's looking like this stop here is at T equals negative 2.5. And we can do the same thing for the other point. I'll use the X again. 0 equals 2 minus T. I just add T to the other side. T equals 2. Does that work? 3 plus 4 times 2. 4 times 2 is 8. Plus 3 is 11. Check. If I plug in 2 for Z, 2 times 2 is 4. Minus 1 is 3. Check. So that will be at T equals 2.5. So that's how the line segments are working. If it kind of helps, the way using this, the vector is kind of like a laser pointer with the cat. Like when you're fucking with a cat and you got a little laser pointer and you're drawing along the ground, that's exactly what these vectors are doing in reality. So I'll have a little laser pointer, and what the cat sees this, and the cat goes running after that. But what I'm doing, I'm not moving, I'm standing here, and my laser pointer, I'm drawing it. The laser is shooting out away from me from the laser pointer and doing this. So it doesn't have to be a straight line. In chapter 12, it's not going to be straight lines. We start with straight lines for parametric equations in 11, but in chapter 12, we switch to curves. It's in every situation, it's much like me standing here, and this is, you know, El Jefe with his little laser pointer. And I don't know, can I do a good cat?
Yeah, do you have a question?
Yeah, so then, okay, so then would that mean, kind of like, just, could you kind of use like a train example so we could kind of visualize what was happening? So then would that mean that if T is starting out at negative 2.5 and it ends at T equals 3, then it'd be like, what would the 5.5 be representational of? Like how long it took for the train in this case to arrive at the ending point, or?
Yeah. So T is like is time. And it's going to work the same when we get to chapter 12. It's going to work the same way with the curves. It's how long does the cat take to follow the fucking laser? You know this is a great analogy, Brandon. You know it is.
It is a great analogy. You have such colorful metaphors you use. And not even in a...
Because the laser pointer you don't see. You don't really see the laser. You just see where it hits.
Yeah.
That's how this vector thing works. You really, the vectors just, we're using it to describe this curve, but all we see is the line. Normally you would just see the line. You wouldn't see all these vectors. I just drew the vectors so you can see what I'm trying to demonstrate. But that's how the vector notation is used a lot. But at any given point, and we're going to get to this in chapter 12, at any given point, I can find a tangent line, like right here, I can find a tangent line. And the tangent line changes. As we move along, the tangent line changes. And so this is where the calculus part comes in. We start doing derivatives to find tangent lines. When we find the tangent line, we can find a line that's normal or bisects the line right there. So that's our tangent line. This is our normal line. And then they have one called binormal that comes out of the damn page. But that's later on. We'll get to that. For now, we're just, the vectors are pointers to where the curve is or the line is. And when we're doing it,
We do have a
'Cause
couple
in-
questions.
go ahead.
I was just gonna say, so when you say normal, you're referring to like orthogonality, right?
Yes, I really wish they had not used the word normal. I have no control over what asshats picked before. Because we have so many definitions for normal. I don't know why we needed to use one that's like, why couldn't we use something that's not used for other things?
For sure.
I don't know why we have 3 words for perpendicularity. Why do we need orthogonal, normal, and perpendicular? And right angle, 4. We got 4.
Yeah, we got a question over here.
I got a question. So this answer would be negative 2.5 to 2.
Yes,
That's 2 or 3.
It's a 3. So it would take 5.5 seconds for the time we travel from point A to point B. Is basically what's happening. Yes.
Yeah, T is perspective, right?
Yeah. Which is what I was asking, it really works with the training example. So if you know that that T is starting out at -2.5 and ending at 3, you can say that to get from the starting point to the ending point, it would take 5.5 seconds.
Right, no, I got that.
I mean,
I was just saying, we don't know, like, the unit.
it's outside,
5.5 is something.
it's outside -1, -3. The original one you gave on the first question,
say that again.
outside, it's outside the range of -1 or 3. So the final answer is going to be -2.5.
For part B is -2.5 to 2. The train's here and the train goes to here.
Why were we able to use the same parametric equations for both problems? I don't get
Because
that.
I didn't want, I wanted to use the same parametric equations for both problems and I didn't want to rewrite it.
They're not separate problems.
Oh,
They're
okay.
part of
I
the same
thought they- okay.
That's why I went with A and B to try to show that they're related rather than writing 1 and 2.
I see.
And were you confused about something
That's why
earlier?
I got confused too. I didn't realize that they were part of.
You figured it out?
No,
I think. Is there any other questions? I think we're good on this end.
Oh. Where are you getting the 2.5 from?
No, where are you getting 2?
Oh, yeah, where are you getting it?
That's whenever you plug in the zeros.
T equals 2.
I
That's where,
solved for them.
yeah,
I plug in the X value into, this is the X parametric equation. I took the X value from each of these and plugged it in. 4.5 equals 2 minus T, 0 equals 2 minus T. So I took these values and plugged it in there. And I took that value and plugged it in there. And then I solved for T on both. That's an arrow. I don't have to use X. I could have used Z or Y. I could have gone with, okay, rather than starting with the X ones, I could have gone with the Y equation. The Y was Y equals 3 plus 4T. And my 2 Y values, 0.1 had a Y value of -7. And 0.2 had a Y value of 12. This green.
The result on how X and Y and Z, I plugged in the T getting a different answer. Now matching for one number, that means the this vector is missing.
oh, you're asking whether, like, if if there is actual, you do get a different answer between them. So I got a question asking if you do get a different answer when you do plug it in, will that, what does that mean for the vector?
It means
So-
whoever wrote the problem fucked up.
Basically.
That's
there shouldn't be
exactly what it
an app
means.
or anything. Yeah.
You
Okay.
shouldn't get time, you shouldn't get different times depending on where you plug it in. It means the problem was created poorly because it should be consistent. It
Okay,
just
so-
means human error.
If not, that means that this vector going that way is missing the line equation we giving.
It just means that the set of parametric equations is just straight up wrong.
Yeah,
That's
it means there was an error made. That's all it means.
There's
You can't,
there's
I
no
tried,
special thing about it. and
if you can't get different time, like if you have parametric equations that are related to time needs to be consistent for all three. That is the
Yeah.
consistent connection. If you solve and get a different time for two of them, it means the problem was set up wrong. Someone fucked up.
Mr. Jones.
And that's why I did the count. I came up with these in my head, plugging in -2.5 and 2. So I wanted to double check them all on my end just to make sure I didn't fuck up. But it doesn't matter which one you use. You should just be able to solve for t when you plug in either X, Y, or Z, and it should be the same across the board.
Okay.
The
We
book
got one
shouldn't
more.
have errors like that.
We do have one more question.
Mr. Jones, so, okay,
Yeah.
so then kind of, just to kind of clarify, like, just for myself, off of the question that he had asked. So if we solve the problem and we solve for t, and then we plug in t back into the original parametric equations, and we don't get the 2 points that we get in the second part, then assuming we did the math correctly, then we, like, that shouldn't happen, right? Like, everything should math out correctly.
Everything should do correctly. If you don't get the same point that you started with when you plugged the time back in, again, double check your work, make sure it's correct. Otherwise, there was an error in the setup in the first place.
Okay, sweet, thank you.
All right. I think we're good on this end. Did you check Zoom to make sure?
Anybody on Zoom have any questions?
No, thank you.
Okay. Would you guys like to see more, or would you like to work together?
Yeah, there's some chat, there's some chats.
Yeah. Yeah, I was asking him to check so it's not taking over the thing. Jeez.
True, wow.
Yee. All right, do you guys want to do other problems or do you guys want to just kind of work on homework? More problems, more problems it is.
Okay, so, god damn it, this green one sucks too. Can I grab the same one again? Fail.
This is good. I'm gonna go.
So where do these lines intersect? We're looking for a point, basically.
Sure.
Good. Don't die, please.
You're doing the shaming.
All right, maybe that'll help get your voice over to the speaker. Now you can see your class without a glass wall.
Yeah, now it doesn't have.
Instead, you just have a glass lens instead.
Where we're having class after.
Maybe I should make sure I do these. These are, I want to make sure that you see that, like, this is L1 on top. This is L2 there.
And no, you know what that means? I get to put it back.
True.
I recommend slide, like grabbing closer to the paper, sliding it.
Yeah.
Well, that's what I was kind of doing, trying to do.
Or you were kind of like had to pick it up. That's like, yeah.
Yeah,
it's like
exactly.
an awkward. Pickup on that. I don't know.
I'm sorry if I don't have abs.
Just use your legs.
But when you're pulling it, you just gotta use your back and do like more like a row.
Or you can do a squat.
That's why it'd be easier because your back's probably stronger than your shoulder. You know what I mean?
Lawrence knows all about the different muscle systems. So if you want to ask him about
I don't think-
contraction or extension.
I think all I have here is just skeleton.
In fact, I'm not going to call them L1 and L2. Let's call them LA and LB.
columns.
Then I can say point A and point B and not have numbers in it,
Let's see.
kind of thing.
I'm trying my best to see if I can capture the entire class.
I was curious, has the results of the survey been tabulated yet?
Yeah, there was a very small minority that want to shift. Like less than 20% of the class.
Less percent of the class didn't even do this, so they're probably.
And I'm gonna be honest with you, math 80 and 81 are gonna be the same way. It's time to get on board with the future.
Future.
The future. I just hope that future isn't just it doesn't mean just like buying all those NFTs that they have on the market. Because right
But
now,
math 80 and 81, Mrs. Redden isn't gonna meet with you on the weekends. You got a good gig going right now.
Oh, I forgot about that. I forgot about that. It's my mom's birthday, so we went somewhere else. No, we had to wait this out, it's just a different one. Yo, that would have been funny if my mom went to the same Starbucks as Mr. John. So I'm bringing my mom to the study session.
oh gosh,
That would have been funny.
can you believe it? They want to do open house. They want to bring their families to see show their parents what they've done. They want to make their parents
Starbucks.
proud.
Anybody's welcome to go to Starbucks. You can bring your family.
Say it again. I don't know what's Starbucks.
The one was just the one on Main.
Caldwell and Mooney.
Okay. Oh, that one. That's a funny one. There's a bunch of them. There's like and then there's Main and then there's like.
Okay, there's actually two ways to do this problem. I want to show the longer way first, because this problem has a unique trait that is not normal and makes a shortcut, but the shortcut usually isn't there. Let's do it the long way. I'm going to focus on using two of the variables, getting this down to two equations with two unknowns. So what I'm going to do is do substitution. Let's focus on line A first. Line A, I've got x plus 1 equals 4TA. Let's call it 4A rather than TA. And then I've got y minus 3 equals A. Well, what I can do is, let's see how I want to say this. If we meet up, these y's should match.
Or you're trying to change it back into.
So I could say y equals A plus 3. And here I could say x equals 4a minus 1 if I wanted. We're going to go to the other equations. Let's look at line B. Line B, again, now I'm going to use B rather than TB. We've got x plus 13 equals 12b. I've got y minus 1 equals 6b. If these y's match up, these y's got to match up. So what I can do is I can substitute this in for that y, and I can substitute this in for that x. So I've got, if I redo this here, the left, I got 4a minus 1 plus 13 equals 12b. And then I've got a plus 3 minus 1 equals 6b. So cleaning it up, we've got 4a plus 12 equals 12b. And this is a plus 2 equals 6b. All we gotta do is get it to, we're trying to find out values for A and B. A is TA, remember, and B is TB. This is just me making it easier to write stuff. So I'll just solve for A in one of these. A equals 6B minus 2. And I'm gonna plug that in over here. Now I have an equation with just B in it. Let's distribute. We got 24B minus 8 plus 12 equals 12B. So I'm gonna move all the B's to the left. This is 4 total right here, so I'll subtract 4 over to the right. And if I do that, I got 12B equals -4. So B equals -1/3. And that's TB. And I can take that in and plug that in and find A. A equals 6 times -1/3 minus 2. And 6 times -1/3 is -2. A is -4, which is TA. Now, the way we check to see if this works is we used X and Y to solve this. We need to plug our results into the Z component because we had 3 equations, in fact, 3 sets of letters, but only 2 unknowns, TA and TB. So we're going to use the Z component as a check here. This was -4 and this was -1/3. So let's plug that in. I'll rewrite the Z's down here. For these guys to match, I should get the same Z when I plug in these values. There is no TA to plug in. This top one has Z equals 1. This bottom one, when I plug in TB, I'm plugging in -1/3. Does Z minus 2 equal 3 times -1/3 is -1? I'll add 2 to both sides and I get Z equals 1. I'm off screen there already. I got Z equals 1 on both. Assuming I didn't fuck up anywhere up here when I plug in -4 and -1/3, I'm going to get the X's and Y's to match, but I need to find out what one of them is. I don't like working with fractions, so I'm going to use the A one. So wait, I'm going a little fast. Let me put that back up there. I'll bring line A down here. X plus 1 equals 4TA, and Y minus 3 equals TA. I'm going to plug in -4. X plus 1 equals -4 times -4 is -16. So X equals -17. And if I plug in -4 here, Y minus 3 equals -4. Y equals -1. And I'm going off the screen.
Yeah, I'm seeing people still try to catch up, so.
Let me stop. Thank you.
Quick hands, Professor Jones.
What?
Said quick hands.
Yeah,
You're right back.
yeah, I'm not pausing. I'm sorry, guys. I should have been pausing throughout that.
Is that a positive? That's a positive now?
Are you positive?
It's a positive 12. I have -12.
I'm sorry.
On and down.
Yes, you have a question.
Okay, so I did it before, but I still got the same team. So, like, let me see what you did.
You're saying you did it in a different way and got the same answer.
Of course, there is an easier way. This problem, I said, I led with that. I said there is
Yeah.
an easier way to do this problem, but it's unique to this type of problem, and I'll show it in a second. I agree, there is an easier way. Normally, that easier way is not present,
Oh, okay, makes sense.
and it has to do with the z component. Z minus 1 equals 0 has no time component in it. So we can take advantage of that in the easier way,
Okay,
okay?
yeah, that makes sense.
You should be getting the same value, same T value.
And we'll do that in a second.
For sure.
Did I hear someone say question?
Oh, you subtracting.
We did. I think
I
we're,
didn't want to lead with the shortcut method because doesn't work every time. This does work every time. Is there any questions what I did so far before I do the easier way to do this particular problem? So let's recap before I switch. So what we did is normally you take all sets of these, and what we're doing is solving, we're setting up two equations with two unknowns. We have these right here, and the idea, this is a linear system of two equations. Pick any two variables and do that with it. Then whatever you get for A and B, and we did that with B over here. So, sorry, those aren't two equations, two unknowns. When we put them together, this was two equations with two unknowns. Let me recap this, like give a little guideline instruction here. How do I want to say this? We know the X's, Y's, and Z's have to match. Match between points.
It's something with the leads though. That's all I have to put the B's and the A, the B and the A.
So we can set up two equations with two unknowns by combining the two. I've got X plus 1 equals TA.
The value, the value, you can put in to find. I don't mind. So I'll say we take these two values. Find
Mr. Jones?
Yeah.
One of the values. And then
So we would end up with how many points? We would end up with 2 points?
this thing.
You should have 1 point.
1 point. If you need to look at the example again, you can find it.
So just a quick recap, what you're doing for each thing, each letter. On X, I solve for X on both of them. Since the X's have to match, these two have to equal each other. I've now got one equation with two unknowns, TA and TB. I'm going to do the same thing with the Y components. So using that right here, I'm going to add 3 over. Y equals TA plus 3. On this one, I'm going to add the 1 over. I get 6TB plus 1 equals Y. They're the same Y, so these two have to equal. I now have two equations with two unknowns. I can solve that. This has a solution. So we should be able to get a value for TA and TB when you solve it. What you're going to do at that point, we used X and Y up here. Plug these into Z, into the third variable, I'm going to say, because if you use Z instead, plug it into the third variable and make sure you get consistency. The third variable should have equal values. Z equals Z. You should get the same thing. In this case, it's going to be 1 equals 1. So that's how you go through and find intersections of lines. If they exist, this situation will happen. Intersection. Z has to match. If Z does not match, if the third variable does not match, like ZA equals 4 and ZB equals 2, the lines don't meet up. And those are called skew lines. Now, shit. For some reason, and I haven't figured out why we've defined it as such, they say these lines, skew lines, live in parallel planes. Which sounds like bullshit, because if I've only got one line, I could say that plane goes like this. I could say, this is my problem with what they've got. If I had one line, I could say the plane is like this. I could say like flat like that. I could say it's at an angle like that. There's a lot of planes that go through that line. Their argument is when they're skew lines, they exist in parallel planes. We're going to use that in the next section. But as it is, if the third component doesn't match, they don't intersect. If the third component does match, they do.
Only the third component?
Well, the first two should match. We use that you very much should get the first two components matching. Otherwise, you solved the equations wrong. You did not, you messed up on the step. There's no way to get the TA and TB here to not work in these if you did everything correct.
Okay, we have a question in the back.
And you say
Yeah.
it's parallel, or you say they're parallel planes, which is there a specific plane they're parallel, or does it like not specify?
They're saying they're parallel to each other. They don't, the plane is not specified.
Does that answer your question? Any other questions?
Like it could
I think
be
we're good on this end.
like that. It could be like that. You can't see they're parallel.
It doesn't define like what the planes
Doesn't-
actually are.
yeah.
It just defines that the plane, they're to each other, they're parallels.
Because when you have a straight line, the plane could picture a piece of paper. Oh shit, let's see if I can generate one.
Draw lines on a box or something.
I'll do something tomorrow to I'll show you a better picture tomorrow on how you can picture up what's wrong with it. The other way to shortcut this problem, let's do that real quick. Because we got
Yeah.
6 minutes left.
Yeah, I think you gotta add.
So if you have this going on, you can take advantage of this to speed it up. I do not have a time component in line A for Z. I'm going to use this. Z has to equal 1 in line A. There is no options. There's no other point. Line A is always Z equals 1. So I can use that in line B. I can say 1 minus 2 equals 3 TB. Negative 1 equals 3 TB. TB equals negative 1/3. Go through and plug that in and find the points. So I'll use line B. X plus 13 equals 12 times negative 1/3. X plus 13 equals negative 4. X equals negative 17. Y minus 1 equals 6 times negative 1/3. Y minus 1 equals negative 2. Y equals 1. I'll pause there because we need, that's just getting the point. We need to make sure the point exists on the other line.
Yeah, that's technically what we're doing. Are you saying that it's TB instead?
Negative 1.
I guess TA and TB.
No, TA and TB are different, yeah.
Yeah, Eli, that's the shorter method. And this only works because this does not have a TA. If they all have TA and TB, you have no shortcut, but this shortcut works here. Now, what I'm going to do for line A, I don't know what time component to use, so I'm going to have to figure one out by using one of these values. Z doesn't work because there's no TA here. I'm going to use Y because it's got a small value. I'm going to plug that in for my Y. And I'm going to have -1 minus 3 equals TA. That's my Y component for line A. I'm getting -4 equals TA. So now I've got the 2 times. Now, just to find consistency, I need to make sure LA works. So X plus 1 equals 4 times -4. X plus 1 equals -16. X equals -17. So I've got -17, -1, and 1 again for line A. It is consistent. We got them on the same one. It's shorter that way. It only works because one of the variables did not have a time component.
Yes, you got a question?
Could you just plug in TV and TA and then set the X's and work, whatever value you're doing. They equal each other, find like what is it? Does that when the top X equal to the Y, the bottom X.
Sorry, it's starting to get a little noisy. You want to come up here?
Up there.
So say it again.
I was thinking, maybe Noah first. She go like that.
The camera's right there.
Everyone else have a good day. I'll see you guys
You're
tomorrow.
if you plug in TA, which is TA is -6.
Oh, sorry. I'm going to be having my SI later today from 12 to 2 in the current 712B. I'll send an announcement later today.
Yeah. That's what I mean, because we have that. We have the. No, that's not gonna work. I guess I could just put it myself. Yeah, no, never mind.
That's why I was like, this doesn't like, there's something weird about it.
Yeah. So.
All right. You better clean up because I kind of made a mess of the room a little bit. So.
Yeah, it's 9 o'clock.
Professor Jones, have a good day.
You too. I'll see you guys tomorrow.
Thank you very